is Alex Kenny, and this is my partner Justin McGrath, and we work with Team SES America on their blanket sign connectivity over cellular network. So what is a blanket sign? Well, a blanket sign is essentially a sign made up of LEDs that have been cut in the middle to display different messages. Now these messages could range from anything to a down arrow, to a no left turn, to anything along that aspect. The messages have been used to change it on site. So what our project is, our goal is to make it so that they don't have to be on site to change these messages. It would take a lot of time, they'd send out technicians, so what we're doing is we're making it so instead of going there, the user can go online and they can enter their password and username in a website, and they can therefore change it through the website, as you'll see later. And now, in order to do this, we had to meet power and monetary constrictions, and we had to allow for secure data transfer, which we did achieve. Justin here will talk to you about our technical accomplishments.
So this is a block diagram of our product. Over here we can see the link out sign as it is right now. The rest all had to be implemented. So we start out, over here the sign needs to be connected to a microcontroller. We chose a Arduino. In the end, we started with another development board, ended up choosing the Arduino because of simplicity and ease of use for setting pins and connecting with the socket. So here we have the microcontroller connected with a cellular modem that will enable it to be able to connect through the internet to a socket that will be hosted on our web server over here. That socket will be able to query the database and consequently check to see if fields are updated and if it needs to be sent out back to the sign. That web server will be responsible for handling requests from the sign and then also pushing out the new information or stating to the sign that there is no new information, don't update at this time. Over here, the very front end is the web application. That will be the actual websites where you can log in, choose whatever sign you want to change, and then consequently change the message being shown. So here we have a live demo of the product in action. I'm logging in over here. As you can see, this little navigation bar popped up after clicking on a marker on Google Maps that signifies a sign. Over here, I'm clicking on different images being shown. Right now, it's about to show a walking man. That's because I clicked on the walking man and clicked on validate to send that to the socket. The socket consequently sends that out through the internet, and then this is received through the cellular network, and then consequently sets pins, and those pins are used are directed to relays, which are then connected to the LEDs in the sign. So that's what actually does the changing of the messages being displayed. As you can see, this also works for mobile applications as well. That needed to be formatted a little bit differently in order to fit the mobile screen. But as you can see, we do have an end product that works wirelessly. These aren't connected in any way to this sign over here. Just a little closer look at the website that we're using right now. It welcomes the user after you go to the website. It will redirect you so that you have to log in order to be able to see this main page here. From there, you can add signs or sign out, and then click on Google Maps marker to be able to bring up this navigation bar, and then you can consequently just change the signs as you want it. Over here, this is just a view of how it looks on the mobile device.
So as you can see now, we'll talk to the board that Justin mentioned a little bit earlier. So where do we get our signal from? Well, the signal comes from Verizon through the internet, which then connects to this board right here, the Skywire Cat1 4G LTE. So that enables us to take the message that we received from you entering your data on a website, and then we connect it to this Arduino Mega. Now we had to use the Arduino Mega instead of an Uno because it has more memory and it has more pins that we could use to implement our relays that he mentioned beforehand. So as you can see, the pins here are implemented in the relays. There's one down here and there's two up here. So now what those do is those actually control the messages on the sign. So those implement here into the terminal blocks, which just connect you to your ground and your voltage and your power supply. Now, for a power supply, what we had to do is we we didn't want something big in our power supply because this had to be implemented within the sign, which is roughly about 2 square feet. So in order to do that, we made it so you could plug from a wall outlet into this 12 volt AC/DC power supply. Now what that does is, well, it puts at a steady current at 12 volt, obviously. And so in order to do that, we managed to accomplish our best goal. Now for the future implications, if we had had a little bit of extra time, what we would have liked to have done is to implement a relay system so that each sign didn't have to have a cellular module within it. Each one could have a radio one, and then the signs would communicate via radio module instead of each one having a cell module, which would cut down on costs. Now, the cool thing about this project is that it can be implemented in stoplights. So now let's say there's a fire truck or an ambulance driving through downtown and you need that vehicle to get there as fast as possible. What they can do, if there's someone in a central location controlling this, maybe a 911 dispatcher, they can set up the street lights in such a way so that that ambulance or fire truck has the right of way the whole way. They have the green light. So now for our acknowledgements, we would greatly like to thank David Connolly, who was our technical director and very influential in our project. We'd also like to thank Phil Peru, who is very enthusiastic about our project and always offered help when he could give it. We'd also like to thank Dr. Hurry Shunak for making this possible, as well as the TACO team for their help in our early development, and the rest of SES for being there when we needed them to be. Thank you.
Thank you very much.